let's talk trapezoids. Trapezoids are going to have exactly one pair of opposite sides that are parallel. So let's label them. You're parallel and you're parallel. And the major property with these is that any two consecutive angles that are not going to fall on the same parallel line. For example, angle 1 and angle 2, not angle 2 and angle 3. Angle 1 and angle 2 are going to be supplementary, meaning I can add the measure of angle 1 and the measure of angle 2 and I'll get 180. Put an angle 4 down here. And I think over on the side we can just say the measure of angle 1 plus the measure of angle 2 is equal to 180, and that makes it supplementary. And we'll say the same thing about 3 and 4. So the measure of angle 3 plus the measure of angle 4 is equal to 180. And that's really the only super special thing about trapezoids that we need to know. I mean, the parallelness creates that. It's that two parallel lines and a transversal thing. But we're going to slide up and talk about what happens if it is isosceles, which means we have parallel lines, and these are congruent. And now we have the same thing we just had up there, to where if I said angle 1, angle 2, angle 3, angle 4, then they'd be supplementary. 1 and 2 would, 3 and 4 would. Now, also, I could say that 1 and 3 are supplementary and 2 and 4 are supplementary. We'll get into that in just a moment. But one of the other things I want to point out is that the diagonals, actually let's do the angles first. Angle 1, angle 2, angle 3, angle 4. Angle 1 and angle 2 are supplementary, as shown above, but so are angle 1 and angle 3, because if angle 2 and angle 3 are the same, which we're going to talk about in just a second, then these are going to be supplementary as well. And then if angle 1 and angle 4 are the same, which we're going to talk about, then 2 and 4 are going to be supplementary, which means this. Let's start labeling. These two angles, angle 1 and angle 4, are going to be congruent, and so are angles 2 and angle 3. So there's one of the big ideas. Now, let's get to the diagonals. The diagonals are going to be congruent because if we did that and we did that, there's a rationale for why this is. And if you really care what the rationale is, it would be kind of a side issue. Nope, I lied. Side, angle, side. So just looking at this, notice that you have a side, and then the angle in between them has the two swooshes. Well, then I come over here and I have the same side, a congruent side, and then the two swooshes. So therefore, this triangle equals that triangle. It's congruent to it. And therefore, these two diagonals must be congruent to each other.